Okay, so we are trying to solve nPr, or prove, I should say, that nPr over r factorial is equal to npn minus r all over n minus r factorial. Now, in order to do this, we're going to work one side to be the other. The reason being that the left-hand side is quite simple, the right-hand side is complicated, so quite likely we're going to work the right-hand side to be equal to the left-hand side. And the reason I choose this is because it looks to me as if I can simplify it. So the right-hand side equals npn minus r over n minus r factorial. And that is equal to n factorial over n minus, in brackets, n minus r factorial, and all of that is divided by n minus r factorial. So as you can see, the left-hand fraction has n factorial in the numerator, and in the denominator you've got n take away n, which cancels, and minus minus r, which is positive r, so it's n factorial over r factorial. And then we're also dividing by n minus r factorial, or in other words timesing by 1 over n minus r factorial, and that leaves us with n factorial over r factorial n minus r factorial. Now that's not too bad. The reason being that the r factorial that's on the bottom in the left hand is what we want from up here in the solution, nPr over r factorial. And so if we kind of rearrange a little and move this over here and put n factorial there and n minus r factorial here, what you'll notice is that this section here is actually nPr. And so because that's nPr, you've actually got here 1 on r factorial times nPr, because n factorial over n minus r factorial is the definition of nPr, and then we can just rearrange that to make it nPr all over r factorial. And therefore the left hand side equals the right hand side equals to nPr on r factorial. And therefore nPr all over r factorial is equal to npn minus r over n minus r factorial. And we're solved.